Now, this question is very straightforward, but to get good marks on it you have to give a complete answer, and basically discussing how the charges on subatomic particles contribute to the size of their atoms and their ions. So we've got to make sure when we're answering this we're really addressing some key things about charges and the size of the atoms as well as ions. So of course naturally you've got to talk about the particles that are present in an atom, about the protons, neutrons in the nucleus, how the protons have a positive charge. The electrons are negatively charged and they basically occupy orbitals surrounding the nucleus, and the attraction between the protons in the nucleus and the electrons is an electrostatic attraction, and the stronger that electrostatic attraction, the smaller the radius. Now, to give a complete answer, we've got to go right from basics. How if we increase the number of protons, we're increasing the amount of charge, we're increasing the attraction. And then obviously we need to talk about electron shielding. So as we go further out, the electrons that occupy higher energy level orbitals will be shielded from that positive charge by some of the inner orbitals, and then you can relate that to what effective nuclear charge is. So if you use a term like effective nuclear charge, you should be able to explain what it is, that it's the charge that the electrons feel, but the charge that the outer electrons are exposed to, but it's been diminished by the fact that we've got these inner orbitals. So it's the resultant charge that they're going to sense, really. And then when we talk about electron-electron repulsion, that electrons will repel to be as far apart as possible. So the more electrons in an orbital, the more electron repulsion there is. The greater the distance they are away from the nucleus, the less the electrostatic attraction. Okay, so those are all things that you need to talk about in a coherent way as you go through that, but you also need to link it to when a cation forms or a positive ion forms, that it loses an electron, there'll be a less electron repulsion. That there'll also be, in some cases, in most cases, it'll mean that it will drop down in energy level, so the distance is going to be smaller, the nuclear charge is going to be the same, there'll be less electron shielding, so the size of the atom will be less. And when you add electrons to a atom and it becomes an anion, that you're increasing electron repulsion, that the distance is going to be greater, therefore the electrostatic attraction will be less, therefore the radius will be greater. So always got to come back to the radius as well on this, because that's what we're really talking about when we talk about the size. So giving a complete answer, bringing all those factors together and making sure you address how it affects the size of the radius, and that's really all down to electrostatic attraction. The greater electrostatic attraction, smaller the radius, the less the electrostatic attraction, the bigger the radius. Okay. Now the answer I've just copy and pasted over from the assessment schedule, because it does a reasonable job of explaining it, and unlike some of the answers in scholarship, this one is self-explanatory. It's just about being complete with describing all of those, showing that you understand all of the factors involved and how they affect the size of atoms as well as ions. And that's that one.